Okie dokie. Chapter 6-7, Problems and Examples. This is all about conservation of energy, trying to make them equal. Okay, now we've got rock is dropped from 3 meters. So what we're dealing with here, so rock is dropped from 3 meters. So that's a potential energy. Calculate its velocity, which would be a kinetic energy. So the first thing I've got to decide is the fact that we're converting from potential energy to kinetic energy. Alright, so let's set the problem up. So my total energy, so we've got a height of 3 meters. So we're dropping the ball from here, and that was 3 meters. We want to see at 1 meter above the ground, what's the speed, and what's the speed at the ground. So let's see what we can figure out. So my height, and then my height final, we want to do 1 meter. Okay. Now, so our energy, our total energy equals my kinetic energy plus my potential energy. Now, in this case, we're talking about a closed system. So when we look at this, my energy, I have all of my kinetic energy plus, so my energy initial has got to equal my energy final. So my kinetic energy plus my potential energy has got to equal my kinetic energy plus my potential energy, or this being the initial side and this being the final side. So initially, the kinetic energy is 0, and I have mass times gravity times height. On the other side, if we're at 1 meter, okay, I have a kinetic energy, it's 1/2 mv squared, but I also have a potential energy this time of mass times gravity times height. Now why? Because it's 1 meter above the ground. Okay? Now, we look at this, masses cancel, so I have gravity times height, which is 9.8 times 3 equals 1/2 v squared plus 9.8 times 1. So that's going to be 19.6 equals 1/2 v squared Now, let's see what we got. So that's going to be double that. 39.2 equals v squared. So I take the square root of that, which I have no idea. It's going to be somewhere around 6.3 meters per second. Okay, not too bad. Now what does this, so what does the scenario look like next? Alright, our next scenario, what does it look like? Well, this time, we were going from 3 meters. We want to end at 0 meters. So what's different? So we have energy initial has got to equal energy final. So we have kinetic energy plus potential energy equals kinetic energy plus potential energy. Now we look at that. Okay? At the top, at the beginning, kinetic energy is 0. At the bottom, potential energy is 0. So, what are we dealing with? Well, potential energy is mgh equals 1/2 mv squared. Masses cancel. So that's 9.8 times 3 equals 1/2 v squared. So what's 9.8 times 3? 2. So 29.4 equals 1/2 v squared. So we're looking at 59.8. Sorry, 58.8 equals v squared. And then we're going to take the square root. And my velocity equals 7.7 meters per second. Sweet! Like next. Okay, let's see what we got going on here. Example number 2. The height of the first hill is 40 meters. Let's get a better color there. Okay, and so we're going to call that 0. And roller coaster starts from rest at the top, the speed at the bottom of the hill. Okay. The height at which the speed will be half. Well, let's see what we can do here. So, height equals 40. Height initial equals 40. Height final equals 0. So it's energy equals energy. So, let's see, shucky darn, there we go. PE plus KE equals PE plus KE. MGH equals, see, that's 0, that's 0, 1/2 mv squared. So that cancels, that cancels. So that's 9.8 times 40 equals 1/2 v squared. Alright. Let's see here. So I got 9.8 times 40 times 2. So 784 equals the velocity squared. Square root that. So 28 meters per second is my velocity at the bottom of the hill. Okay, so we've got to finish up on the second one here. Now the second one's a little tricky. So let's see what. Okay, so this time we want the final velocity. So velocity initial is 28 meters per second. Velocity final equals half that. So 14 meters per second, according to my problem. We know that the initial height this time is 0, and the height final is what we're looking for. So we're going to set up, we know that energy initial has got to equal energy final. So that's kinetic energy plus potential energy equals kinetic energy plus potential energy. Alright, now let's see what we've got here. Let's see if anything cancels that. So we have 0 potential energy. So we know that 1/2 mv squared equals 1/2 mv squared plus mgh. My masses cancel. Now I have a number for everything but h. So like that's going to be pretty good. So I've got 1/2 times 28 squared equals 1/2 times 14 squared plus 9.8 times h. Now let's see here what we got going. Now we got 0.5 times 28 times 28, 392 equals, see, 14 times 0.5 equals 98 plus 99.8h, 392 minus 98 divided by 9.8, so 30 equals the height. So 30 meters, not bad. Alright, let's see what we got, what else we got here. Okay, example number 3. A dart of mass 0.1 kilograms is pressed against a spring in a toy dart gun. The spring constant is 250 newtons per meter. The spring is compressed 6 meters. What speed does the dart acquire? Alright, so we're going to start out the same thing. Energy equals energy. So we have energy initial and energy final. Now, the energy of a stored spring. So we're talking about what speed. So we're going to have kinetic energy plus spring energy. So that's potential energy again, right? Equals kinetic energy plus potential energy. Alright, see what we got going on here. So kinetic energy goes to 0, potential energy goes to 0. Sweet! My potential energy to the spring is 1/2 times K, the spring constant, times the distance that it's compressed squared. And then my kinetic energy is 1/2 mv squared. So we got 1/2 times my spring constant, which is 250, times my, now that's 6 centimeters. So that's 0.06 squared equals 1/2 times my mass, 0.1, times my velocity squared. So let's work out this. So that's 125. It's 125 times 0.06. So I got 30.45 equals v squared. Okay, divide. That's 609.2 equals v squared. Square root of that. At 24.7 meters per second is my velocity when it comes out of the spring. And I got it wrong. Well, let me look. Okay, I dearly love the calculator on the iPhone. So what I've got here is an error. So let me see if I can try this again. Alright, let's try this again real quick. Okay, kinetic energy plus potential energy equals kinetic energy plus potential energy. Okay, so kinetic energy is gone, potential energy is gone. equals 1/2 mv squared equals 1/2 kx squared. Okay, so that's 1/2. Well, how about we do it this? Okay, 1/2 times 250 times 0.06 squared equals 1/2 times 0.1 times the velocity squared. Now what happened was I used the wonderful calculator on the iPhone and it gave me 30.45. It should be that. So this is 0.5 v squared. So divided by 0.05 equals 9. Take the square root, I get 3 meters per second. This is velocity. There we go.